It's a high-tech conversation
and a low-tech topic.
live on the World Wide Web via Zoom. Bench Talk 101.
Hello, good evening, everyone. Welcome to Bench Talk 101. This week we have Ross Alcock here, who's going to talk about clockmaking and how he designs a clock. Ross is a horologist, and he's going to tell us how to tell the time. So over to you, Ross.
Thank you very much. I would start by saying which sort of time do you want to learn to tell? Because there's solar, mean solar, railway, sidereal. They're all slightly different takes on themselves. They all average out. That's a sidetrack. Right. As been said, I'm a horologist. I'm actually a clockmaker. Horology covers a very, very broad spectrum, and I know we've got at least one other horologist in the room tonight, because horology is anything that marks the passage of time. If you look in the Oxford English Dictionary, it's the art and the science of timekeeping. So I do a very, very small part of it. I do clock repairs, conservation, restoration, and I design and make when I can find people with deep enough pockets. So I'm not a woodworker. I can't work wood. Me and wood have a very, very unhappy relationship. I usually end up with matchsticks, but I appreciate and admire what everyone else does with wood. But you can make clocks from wood. If anyone's come across John Harrison, who gave us the forerunner of GPS, I've got a nod there from somebody. His early clocks were made out of wood. He was a carpenter by trade. You just have to lay the grain, you make the gears in segments and what have you. And one of his wooden clocks at Bewley, they stopped last year for maintenance. I'm not sure if they're going to restart it. And the reason I got involved in the woodwork side of it is I'm the one, hang on, let's see if this works now. Share screen. Share. I developed that over the course of lockdown to help support small local businesses and me. And it's a natural furniture polish, so I know some of you have bought it and seen it. It's quite a soft wax, so it's not holding up well in the heat today. So let's just, how do I do this again? Get rid of that. Screen share and stop. Okay, so that's where I got into woodworking from. And I'd use it predominantly on case restoration repair. But designing a clock from scratch, or in my case, designing something that's got to fit something that's 200 years old and full of wear, where do you start? Well, the first place I start is share screen. I have a number of resources that I use. And I've now lost them. Excuse me. And the first place that I would recommend you start if you want to get into this is you start with, lost the buttons. Share screen, that one. So I started with Practical Clock Repair by Donald DeCarl. I don't agree with everything that's written in this now. In fact, in clockmaking terms, it's known as 1001 thing to do with a hammer, because at some point his attitude is hit the bugger. But if you're designing a clock, it's got enough of the basics in for you to be able to see where to go and what to do. It also carries a lot of data in it that, come on, let me scroll through. So it carries a lot of data that means you don't have to work the maths out. I hate maths. I'm not good at it. I can never remember how to use it. I just remember where to find it. And if you think of a clock has two bits that we're interested in. The bit that tells the time and the bit that tells it how long it's going to run for. and we start with the Center Arbor. The Center Arbor it carries the minute hand. It goes around once an hour. And everything above that tells you how quickly the clock's going to run, how quickly it's going to tick. Everything below that tells you how long it's going to run. So if I go into decal, and I can share that one. Let's share the share screen. That one. This is the table where I would always start. If you want to do watches, it's the same process. You just end up with much bigger numbers. So center wheel is down the left-hand side. Everything's worked out from there. And I always start by picking the pendulum length. How big do I want this to be? How many times do I want to go tick every second or every minute? Yes, it's in inches. I'm metric. You get used to bouncing between the two in clockmaking. For our American friends, it's perfect because I believe you still use inches commonly. So you can, if you want to, sit down and work all the maths out and work all these numbers out, or pick numbers that suit you once you know what length pendulum you want or what length pendulum it will give you. I don't see the point when you can pull it out of a book. So that's where I would always start. Then I create myself a brief. So how big do I want it? How long do I want it to run? That then feeds into all the maths, and you get a list of numbers. And that's where how am I going to produce it is another thing I look at before I even start designing it. One I'll show you later is a clock designed for someone who's never built a clock. So there's a lot of repetition of parts and numbers. So you can produce them either stacked together or in separate poses and practice repeating the processes. So it's one of those things, you have to come up with where you want to go first. A bit like when you're making woodworking projects. You can't just sort of dive in and go, I'm going to make a table and end up with one leg because it falls over. You have to do a design and a bit of a brief. And I'm a fan of Excel because I can plug it all in once and I can walk away from it and I just change all the numbers to work out what I want. So once I've done I'm not going to show you the Excel spreadsheet because it's just a page of numbers. So that gives me the base, the clock, and then I get into the technical side. What escapement do I want? Do I want a deadbeat escapement? Do I want a recoil, which is easy to make? And you can tell a recoil escapement on a long case clock because the second hand bounces. Go forward and then go back slightly and then go forward again. Whereas a deadbeat will go forward and stop. It beats dead seconds. So you'd use a deadbeat for scientific observations. You wouldn't use a recoil. They were developed in around about 1665 for the recoil and 1675 for the deadbeat. Before that, we had the Verge, which is not inaccurate. You can get it to within 3 or 4 minutes a day. But when your day is governed by sun comes up, get up, sun goes down, go to bed, 3 or 4 minutes is not a lot. But it was no good for scientific work. But that was in swing from the earliest mechanical clock in the UK, which is reputably sold to the Cathedral 1386, right up to mid-1700s. So if you're going to use a verge escapement, you have to have an odd number of teeth because the pallets work across the axis of the wheel. So the teeth stick upwards like that, and the pallets work across it, and you have to work the pallets on a tooth and in a gap. So they'd always span a number of teeth and a half. Otherwise, if it's a whole number of teeth, they both crash into a tooth and it doesn't work. So if you want a verge escapement, you have to tweak the train counts. And they tend to be quite short pendulums anyway. They tend to only be about that long. but the maths works for recoil or deadbeat or pinwheel if you want pins sticking out the side. There are a number of ones you can work with. So from there, I then move into, I use Fusion, and I've got 2 drawings to show you. Open. I'll put the first one up. It says when he finds it again. So, share screen. Fusion. So this is the beginner's clock I was talking about, the hook and spike movement. Now, can someone please nod? If I move this, will it actually show you that it's moved? Right, that's great. I've got a nod. Fantastic. So I would start with a model like this. And I start actually in the center and draw the train first. So if you look down the side, you've got my components, and I like this because I can turn stuff off. So let's turn off a load of stuff. Where we get to, turn that off. So I start, and I always start with, let's draw the train first. There we are. And then draw the plates around it. So if I zoom in, move you so I can see me cube, that's it. So this is the escape wheel. It's an anchor recoil escapement. So every time this pallet goes in, it'll push the escape wheel back slightly. That's the bounce you see. As you can see, this one spans 1, 2, 3, 4, 5, 6, 7.5. So this one actually works in the gap. As that comes out, the wheel will go forward, and this one will go into the gap. And I draw all the wheels and the pinions as they would be cut, because it helps you work out where things will go. The other beauty of Fusion is I can colour them so people can actually see what they should look like. And I start with the train. And I will literally start with the moving pillars. And I'll start usually with the center wheel. And I will work upwards and down from that. Because that allows me to see, the problem you find when you're doing clock design is, if you're doing it in 2 dimensions, getting this layout is hard work, because you're always looking at it flat on as a series of wheels. And if I was drawing it by hand, it would be circles. I wouldn't draw every tooth. It'd take me forever to draw 120 teeth on the great wheel. But this allows me to manipulate, change how it looks. So if I looked at it and went, I don't like it in a straight line, I can very quickly move this one out and bring this one down, so it sort of goes up and out and back again, which is the typical arrangement. Because when you depth the gears in a clock, they're never ever the perfect size. You never actually get them the size the math says they should be, because it's always something with about 4 decimal places after it, and you can't measure to that. So you make them and you put in the ones that have got to be in a specific place. So the center wheel's got to be in a specific place, because that goes through the center of the dial. That can't move. The escape wheel and pallets go in a specific place because their relationship is fixed. And very often you put the pallets in first. So you can find that the third wheel, this is known as the third wheel, because you start counting at the great wheel, 1, 2, 3. If it was a watch, it'd have a 4th wheel. Might not fit, it might be too close, and they then butt, and they won't go round because the teeth are too engaged, or they're too far and they do that and they touch tip to tip. So what you do is you make that distance closer to that than is theoretically needed, and you basically put the wheels in a big set of compasses and get the depthing to feel right, and then you scribe two arcs, and where they cross is where you drill the hole. So like you would have done at school when you drew the flower with the compass or bisected the angle. So it doesn't actually matter where this one goes unless you want it in a straight line. And what I would do with this one, wanting it in a straight line, is I would actually put my hole for that one in, depth that one, and then depth that one to that one, and then put the pallets in. So even in the design stage, you have to work out how you're going to actually make the thing. I'm going to try and open. No, come on, open. Plot movements. See how much computing power we've actually got now. So this is a regulator that I'm working on. The wheel counts are much higher, so there's more teeth on the wheels, there's more leaves in the pinions, but you see how it's stepped out to the side? So what I would do is put the center wheel in, put the escape wheel in, and then I don't actually mind where that one goes because it's not related to anything. And so the other beauty of Fusion is you can draw all the. You see this one's still designed, but the arbor's too short. It's not the right length yet. But you can take a quite complicated model and very quickly get a set of working drawings from it. Go away. I don't want that. I want that one. So from that model of the first clock I showed you, I would then produce. Sure. There, a set of working drawings. So I like to work on A3 because I find A3 I can stick up on the back of the bench, and it doesn't matter whether I'm on the bench or on a machine, I can read the drawing across the workshop. Anything bigger than A3 gets a bit too big to sort of handle. So this is the drawing for the escape wheel on the hook and spike clock. That radius doesn't matter. I will make a fly cutter for it. I just need a number to aim at. I'd probably make it 5 rather than 5.5 because I've got a radius gauge of 5. Has anyone ever done any fly cutting? No. Well, fly cutting is a single point cutter that's that shape, and you go through in one cut and you run the cutter. If your machine will do 2000 RPM, you run it at 2000. If it'll do 2.5, we'll run it at 2.5. You can't cut it by hand. Where's my? I also like when I design clocks, I like to do something a little different with every one that I do that not everybody does. So it could be crossing style. It could be, where have I hidden it? The motion work in this case. So this is motion work. All the motion work does is take that one rotation an hour and take it down to 12 to 1 or 24 to 1 or whatever you want it to be. Napoleon tried some metric time at 10 to 1. So this works. It's not a gear, and basically the daisy wheel doesn't go round. It goes in an eccentric pattern, but doesn't actually rotate. And each hollow pushes a set of pins round one more hollow every time. You need the spider to go with it. So this piece sits over the top of it with 3 pins. And if I go back to that one and turn off that. Scroll down and find the stop pinch. There's the daisy wheel and there's the spider pins. So And you see how the pins sit in the hollows, and as this goes round, it'll push that pin upwards, and this pin will drop into that hollow, because it's actually, where's the spider gone? Because the center of the daisy wheel is not on the same axis as the spider, it's on an eccentric. So the daisy wheel doesn't go round, it does that motion. So where's the eccentric gone? Not the spider. So there's the eccentric the daisy wheel sits on. That's where the center arbor comes through. So this piece goes round, but the daisy wheel doesn't go round. It just goes up and down. Can you see that? Yep, I'm getting the nods. And I'm a fan of technology. So once I've done this sort of design, I will then convert it into 3D printed patterns, usually double the size, which I then put on my pantograph and profile out. So I haven't got to cut this shape by hand. I can actually cut it out on a pantograph and profile it. So I'm starting with a formed blank that needs finishing. So that's the design side from Fusion. The other books I'd recommend are, hang on, I'll get back into new share. Then the book's gone. Have you got one book on the screen, or have you got a list of books?
The list of books.
You've got a list of books. My apologies. Hang on a second. Get rid of that. Open that. Open that out. Sorry, I'm not used to Zoom. Skype I could manage, but they changed everything. Share. So I have lots of books, but I reach for 3. So whenever I want to design an escapement, I'd reach for this one. They're on the affordable end of watch design books, or clock design books. Clock books can get, I suppose, a bit like woodworking books, hellishly expensive. There are certain books, if I see for under £1,000, I'll buy. I don't care what the price is. These are about 30, 40 quid each. And in here is all the technical details to actually design the escapements. So you don't even need to work it out. It's done for you. You've just got to understand it and copy it and scale it to the scale you want. I know I've got a picture of a book in there. That's no. Come on, Ross. Okay, go away, that one. Pictures. Sorry, I thought I could scroll through them as a slideshow in Zoom, and it won't let me. For some reason. Share screen. No. So this is a deadbeat escapement, and it's all angles. It's just physics. Excuse the clock that's going off. That's one on test. So when you read through the text, it tells you what all the angles are and why. But basically, what you've got is an entry pallet, an exit pallet, and the wheel rotates in a clockwise direction as we're looking at it. And the clock drives the pendulum doesn't drive the clock, because every time connected to this is the pendulum. So every time one of these teeth slide across one of these faces that are angled, it just gives the pendulum a little push every time it goes through. So every time a clock goes tick, it's just push the pendulum just to keep it swinging. You understand what I'm... Yeah? The pendulum decides how fast the clock's going to go. So if you shorten the pendulum, it'll run much faster, but it still gets pushed at every tick. It's a bit like the accelerator pedal on your car. If you push it down hard, the clock will go the car will go faster. But the accelerator pedal doesn't drive the car; the engine does. So you don't even need to understand how it works if you can read and copy the maths. These tended to be the only bits in Harrison's clocks that were metal. And he didn't use this form of escapement because his biggest thing was, I don't want oil, because oil degrades, oil becomes sticky, oil increases wear. And anyway, you've got sliding action, which you'd have in this corner here, you're going to need oil. Fortunately, with better oils today, we don't worry about it so much. The final book that I would recommend would be, hang on a second to get back to, for anyone that wants to look at clock design, is this book, which tells you how to do all the maths to actually cut the wheels and pinions. All it does is wheel cutting. So in here is all the maths to work out all the different types of cutters, all the different types of tooth form you can use, and how to produce them. Don't ask me. I reach for the book. Even now, I don't remember the formulas. I'm sure lots of you have got favorite books that you've got. I can't remember how to do such and such. I'll pull that one off the shelf because I know it's in there. I use this one. So the next bit I've got, which is the last bit of fun and games, just looking at the time. And I know that you like to keep us to time. I've got some tools that, let me open them up. I've got some tools that we use, take pictures, and I just wondered if people would be able to guess how, or have some idea of what they are. So if I put them up one at a time, let me shut the window that's open and we'll close that. And if someone wants to have a guess as to what they are, and then we'll tell you what they are and how we use them. Is that? So we'll start with. So anyone got any ideas?
Put your name in the chat.
I can't see the chat.
No, but I can.
You can. I'll give you a clue. This bit slides and there's a chuck hiding in here. No?
Matthias?
Some sort of eccentric, I mean, the left-hand end of it looks like an arbor that would fit into some sort of, I don't know, turning or drilling equipment. So some sort of eccentric arbor?
No, it's for actually drilling down the middle of things. This piece fits in the tailstock of the lathe.
Yeah.
And it's for when we've got to re-pivot a wheel that's been damaged. You can very often have very little to hold it on. So it's sort of, you're holding it right on one pivot and it's out here somewhere. So it's trying to do this on you. So in here is a little drill chuck that holds drills. You can see two of the collets up at the top.
Ah, right, yeah.
This has got various holes that match the drill sizes, which have then got a little cup on the end, like a female center.
Mm-hmm.
So you push the arbor into the female center to support it, and then you push the drill through the hole, so the hole goes down the middle of the arbor. So we could, once we've drilled the hole, we can then take a piece of pivot steel to, turn a very thin taper on it, very slight taper, and then tap it into the hole and friction will hold it. But you've got to get the hole down the middle of the arbor, which when it's the best part of 3 inches from the headstock, on something that's never straight and is going around in circles like this, you
Yes.
struggle to do. So it's basically a drilling guide for very, very fine, pure carbide drills. And the largest in there is about 2 millimeters.
Blimey.
And this is down at sort of 0.8, 0.7. And I do have smaller. I go down to about 0.3. So, right. Share screen. It's the same tool in 2 different sizes.
Let's see this again.
So some sort of balancing equipment. It looks like you could suspend a wheel on its axis between those 2 points.
You're halfway there. It's not a lathe, Richard.
We've got another one from Richard. Yeah, you've already.
Oh, yeah, I found the chat now.
Oh, okay, brilliant.
You remember when I said we don't actually mind where the third wheel goes if we're not putting them all in a straight line, and we depth them?
Yeah.
You would put one wheel in here, one wheel in there, and then you can open and close it until it actually feels nice and meshes properly. So we can't produce it to. Give me a second. They're still sat on the desk. Oh. So it's a large piece of kit. So you can pull the runners out. I haven't got a pair of wheels to put the wheels in. And then, yeah, they've got some very, very sharp points on one side and a large one on the other. So you put that in the hole that you know, put it like that, and then scribe your arc so you can get the right spacing for where you want to put the center hole for the wheel that meshes with it. So if we go back to that one, excuse me a minute, right, and new share. So that wheel's fixed. We know where that is. That wheel's fixed. We know where that is. We don't know where this one is. You'd put that one and that one in the depthing tool and make them mesh properly and strike your arc. And then you put that one and that one in the depthing tool and make them mesh properly and then strike your arc. And you'd end up with a cross here to tell you where to actually put the hole for the pivot in the plate. So that's a large one for clockwork. And where's my dinky one gone? And you get the little one for watchwork. So watches and clocks are the same. The tooling just gets much smaller. So yes, there's points on the outside I use to scribe the spacing. Sorry, I've just seen the chat. Right, new share. Now this is watchwork more than clockwork, I will admit, but it does cross over. Nope.
It does look like something that would make the prisoner confess very quickly, but...
No, it's not for making prisoners confess, I'm afraid.
That for pushing pins in?
Nope. It's a poising tool. So when you have a watch balance that oscillates backwards and forwards, you don't want a heavy spot. So you take the balance and you put it on the two knife edges and you let it roll, and the heavy spot will fall to the bottom. And then you can either take a little bit of weight off the heavy spot using a spade drill in your fingers and just rotate it to take a very tiny burr off, or you can add a very tiny, if it's one with screws on, you can add a very thin washer to one of the screws at the top. And eventually you should be able to stop it in any position and it not want to sort of go down and find the heavy spot. So it's for balancing balance wheels. I've got two more. This is a rub your head and pat your stomach one. And that's not wood, it's the disc at the back in the middle is not wood, it's toughened. But you could use wood.
I think we're all from it.
For polishing pivots.
It's not for polishing pivots, it's for polishing screw heads. So you put the screw in the collet in there, and these are all the various sizes collets, and then you rock this piece with one hand, and then you can rock the laps with the other hand in the opposite direction, so you're doing that with it. And it's for polishing predominantly chronometer or regulator screws that want to be absolutely dead flat. You can polish them to a mirror finish using the various laps and polishing compounds. And the last one, and then I'll take questions because I know that at least one of you has got questions. Now, in the ends here are two jewels and they are sprung loaded. And they can disappear down. And again, it's dinky. It's
Pushing bushings on?
nope. So that's the tool. It's for checking the flatness of balance wheels. So you put a balance wheel in and you spin it and use the pointer as a fixed reference and making sure it's not doing that. And then you can push the two together to support the balance staff in the middle and then bend the balance so that it runs flat and doesn't wobble on you. So that's me. I'm going to shut up now unless anyone's got any questions.
Well, cheers, Ross. We're going to move over to the questions then. If anyone hasn't joined before, anyone who's new here tonight, the usual way we do this is we ask you to pop your name in the chat and you'll be asked to unmute when it's your turn, in order of the names in the chat, to ask your question. So some of those veterans have already preempted this and popped their names in the chat. So over to you, Jim.
Thank you. And that was eye-opening. I've watched Chris Ramsey. We talked about Chris earlier and watched him playing with some of his masterpieces, and it doesn't explain the construction, and going into Fusion 360 is I don't know, it hit me with a kind of shock. I didn't expect horologists to adopt that sort of high-tech stuff, but sort of, I expected little sort of cobweb rooms with files and just working from pieces of paper templates and stuff like that. So brilliant. My question. Sketches. Oh, sketches, yeah. Question is, relates to your brief reference to the man, Harrison.
Yep.
H1, the
Yes.
use of the lignum vitae has always intrigued me. Now, my assumption has been that the lignum vitae was there because of what you mentioned, again briefly, the oiling issue, that it is actually self-lubricating, and
Yep.
so therefore the meshing of the cogs and so on and so forth. Is that a correct assumption?
Yeah, he used lignum vitae bearings because it's bloody hard. I don't know if anyone's tried to work it, but it's like trying to work concrete. But because it's that natural oil and naturally oily, you don't need lubrication. So you don't need to add oil, but because there's no oil there, it doesn't attract dust and therefore wear. Because does that make sense? Because the wood's naturally oily, exactly. You don't need to add more oil.
Yeah, that's
bimetallic strip that turns your kettle off.
What confused me a little bit with the use of it is, having used lignum vitae extensively with various things like mallets and gauges and so on and so forth, that its tendency to, at least at some point, settle down and start, you get checking in quite not a destructive way, but it's just almost like artistic checking. During the voyages or the anticipated voyages of H1, wasn't there any consideration as to the effect of relative change of temperature and humidity? I know he had a regulator built in, but the actual destruction of the mechanism itself is what I'm looking at. How did he anticipate, or did he then change his mind and decide that in later up to H4 that wasn't what he wanted to do?
He changed his mind, except by the time he got to H4, he got to use oils, which is right. Why if you go down to the National Maritime Museum or Greenwich, I can't remember which end of the hill they are now, they run H1, 2, and 3 because they don't need oil, but they won't run H4 because it does and will therefore wear out. But as to why the wood, what he thought about the wood checking or cracking or splitting, I don't know. I'm not a woodworker. I just know that say his clock in the stately homes have been running 300 years and not had a problem.
Yeah, I mean they've got it running now again, and in the observatory, which is next to the observatory itself, and it's a purpose built. It's worth seeing if you haven't seen the modern one. It's worth seeing the time exhibition because it's fascinating. Thanks for your time tonight, Ross. It's a completely different subject,
but still a craft, still a heritage subject, and still
correct.
dying.
Right then, now we move to across the pond to Chester. And sorry, I forgot to add Jim as a spotlight there. I apologise. There we go.
Sorry, Jim. Very nice talk. I feel like we've just sort of brushed it lightly through the amount of things that would be required to actually design or build a clock. My question is not for you to tell us everything else, but I have two. Well, I have several clocks. I have one which is an Atmos, which is an atmospheric clock, and it works on a bellows, and it works on the barometric pressure. And then I have a mission style clock that has a pendulum, and then I have a French clock made for Tiffany in France in the 1800s, and it has a little key. It has two keys, one for winding, and it has a top one for adjusting the speed. The mission clock doesn't seem to have any adjustment for speed except moving the weight up and down the pendulum. And the Atmos clock, I have no idea.
The Atmos clock, I'll hold my hands up. Don't speak to me, go to Jaeger.
So what I'm wondering is, or my question is simply, how extensive can these gears go? How many gears can you go? I mean, they must have a separate one in the Tiffany clock for adjusting that speed. They must have some sort of armature or something to do that rather than the pendulum.
No, what's happening?
Great question.
I've got one kicking around the bench. So at the top of every pendulum, you have a spring or a suspension, which on a French clock would be spring steel. And basically what they do on a French clock, on an English clock, we hang it on the back and we tweak the nut on the bottom and raise the bob up and down. Same with an American clock. On a French clock, they have that, and that's what they call course adjustment. And at the top, they have a block that goes either side of the spring and just gently touches the spring. And the little square at the top moves that block up and down on the spring. So you because when you want to regulate a pendulum, you want to change its effective length. So that's the length from the bend point to the center of mass in the bob, which is actually just above the center of the bob because you've got all the rod above that. So you either move the bob up and down, which is quite coarse, or you can change where the bend point is in the spring by fractions of a millimeter. So you can get it close with the bob, and then you put your key on and you move this block up, and you've only got 4 or 5 millimeters of adjustment. So but you can move it literally 1/10 of a millimeter at a time.
And that French clock keeps time impeccably. It matches my cell phone. I mean, for a week, and it's right on. Whereas the American version, which with the pendulum that you have to adjust at the bottom, you're always tweaking it because you don't know a quarter turn. You have to stop the pendulum to do it.
Yeah,
tweak works.
As a rough guide, 1/8 of a turn is about a minute a week.
Oh, wow.
As a rough guide.
Right.
But the difference is the French one was produced by highly skilled craftsmen, and almost it's not a one-off, it's mass produced, but it's someone like me will get all the raw bits and then would polish them and finish them and fit them. Whereas the American ones were produced to a price, and they've got stamped out components, and they are literally mass produced and put together. To the point when they sent them over to the UK, the government bought the first 3 boatloads and destroyed them to protect our clockmaking industry because they said you couldn't make them that cheap. And it turned out the 4th boatload came over, they let them in.
Well, I have to say it's fascinating, and thank you for coming on and showing us some of this stuff. I just know that there's probably 100,000 more things to learn about that, and you're probably still learning, and we're at the back end of things. So it's very fascinating. I think it's great that you're doing it.
Everyone's still learning, but it's nice to be able to share even a glimpse into what we do.
Well, we appreciate it.
Thank you very much. So where have we got to?
Very much for your question there, Chester.
Oh, yes. Thank you.
Move over to Paul.
Hi, Ross.
Oh, Paul. I don't get a picture on this one.
Yeah, we've already got the wax. It's good stuff.
What's your question?
So, when you actually, I'm going to go at the woodworking side of things, which you'll hate me for. But you know, when you actually start with the actual cases,
yeah.
What's your initial cleaning regime?
My initial one is I would start with a dry feather duster and get rid of the dust. I would then move to a proprietary case cleaner. I favour a brand called Curator from Horological Solvents, and it's a white milky mixture in a bottle, or any general sort of varnish reviver that you'd normally use.
Right.
Either on 0000 steel wool or a Scotch-Brite pad, particularly if it's an oak case. Because if you use steel wool on an oak case, it'll go black.
It will indeed.
And then a furniture polish. I tend to use, now I've got my own, I use my own wax, which is just a beeswax polish. If it needs anything more than that, it goes to the cabinet maker and goes French polish.
Right, okay.
If it needs any repair work, it goes to the cabinet maker.
Right, okay, I see.
I'm a big believer of one man, one job, do it well, but have an understanding of everybody's job.
Yeah.
So that you can talk to them
in their terms.
Professionally. But as soon as it needs any more than a basic clean and wax, it goes to the cabinet maker.
Excellent.
So sorry, not much help on that one.
No, it's just interesting. I just wanted a rough idea. As I say, I mean, I bought this from you because from the club quite a while ago, and I really like the wax.
Oh, you've actually got the wax, have you?
I've got the wax.
And you like it then? It goes on nicely.
It goes on nicely. It's nice because it goes on easy. It's probably not as hard wearing as some of the waxes which are out there, but it's just nice because it's easy to apply.
Yeah, I must admit, it's on my coffee table at home. It does wear quite well.
Yeah. As I say, I mean, bright, and it doesn't have all the solvents of the Bry wax.
Nope, there's no solvent in it at all.
Yeah.
So, thank you very much.
Okay, I'm done. Thank you very much for the talk. It was very interesting, and just like Chester said, a glimpse into a whole different field. I think I've had my time now anyway.
Cheers, Paul. Over to Matthias.
Yes, so again, I will start off by saying what the other said. Thank you very much. This was absolutely fascinating. I mean, quite frankly, I'd be happy to listen to this for 3 hours so you could get into some proper details. But to link your job into the woodworking aspect of it, when you're designing a clock, so when you're not working on restoration or something that already exists,
yeah.
It's what is most often the chicken and what is most often the egg. So is it case first and a movement to fit, or a movement and then build the case around the movement? Or is it some one of the 12 of the one or a dozen of the other?
I tend not to design cases. I tend to design skeleton clocks and movements.
Ah, right, yes.
But I will generally start with what type of clock do I want to design, whether that be table clock, long case clock regulator, wall clock, because that then gives me the sizes I've got to play with. Because there's no point designing a table clock with a 1 second pendulum, because that's 39 inches long or 994 millimeters. You've got to, that dictates the size.
Yes.
And then if I can't make it look pretty, then I design a case.
Yeah.
It not being a woodworker, not being able to make the case, I tend to start with a movement.
Yeah.
And then work that way. And once I have built-in cases, I've designed the movement and then carted up all the paper drawings, because the cabinet maker doesn't use Fusion. The cabinet maker doesn't use a computer. So I then cart up all the paper drawings to my cabinet maker and go, let's talk about a case, because there's no point designing something that he can't make.
No.
And not being a cabinet maker, I don't know what you can make and what you can't. And he has quite a lot of input in, I can do that, but if we did this, it'd be easier.
Right.
This is what I was saying, one man, one job, but you need an understanding of each other's.
Indeed, absolutely.
Each other's jobs to be able to work together.
Yeah.
So hopefully that answers the question for you.
Oh yeah, absolutely. You make it sound as though you usually work with one cabinet maker. Is that correct? Or
yes, I have one cabinet maker that I trust and one cabinet maker that I will use.
Yeah.
And I've known my cabinet maker now for getting on 15 years.
Yeah.
Unfortunately, he's the other end of the bloody country.
Right.
But yeah, I tend to have one cabinet maker, one dial painter, one glass person.
Yeah.
And once I found a good one, I stay put.
Yeah. Yeah, you're talking to a man who hasn't changed his hairdresser for I don't know how many years.
When they all retire, I've got a problem.
Exactly. I know it. My previous one stayed in the job until I think he was 92 when he retired. So that's a fair go. But anyway, Thank you ever so much, Ross. It was fascinating.
No problem. Thank you very much.
We're over to we're over to Richard Hughes.
Good evening.
Evening, Richard.
Two questions. The first one is, are you able to recommend a book on clock repair rather than clock making?
Yes. Where I put it. Watching Clock Making and Repair by W.J. Gaisley.
Just making a note of that.
Or Practical Clock Repair by Donald DeCarl. They are very dated in the way they approach things. They are not the best methods, but they work and they're a good starting point.
Practical Clock Making by
Practical Clock Repairing by Donald DeCarl.
By Donald
DeCarle, D-E-C-A-R-L-E, 2 words.
D-E and then C-A what?
R-L-E.
Donald DeCarl. Okay, thanks very much.
I say they're dated, they're not great, but they're the best out there that you'll get, that you'll understand.
Yeah, okay.
I can give you many others that you'll look at and go, I don't understand a word of what this is saying, because it's written by clockmakers for clockmakers, whereas these wrote by clockmakers for the general public.
Yeah, okay. So that's what I'd be looking for. Something as a starting point.
So either one of those, or the Clock and Watch Escapements by W.J. Gaisley, because that's just escapements.
Yes, okay. That's the one you mentioned before, yeah.
And as a student, they were my first 3 books.
Right. Okay, so my second question is, have you ever had any dealings with making or handling clocks made of wood?
I've got a postman's alarm in from the States at the moment, which is wooden plates.
Yeah, but I'm talking about wooden clock mechanisms.
No.
No.
So the closest I get is a postman's alarm clock, which is wooden plates with brass bushers pressed in.
Yeah.
And they're a pain because everything moves.
Yeah. Okay. So somewhere I've got a set of plans for making a wooden clock, and it's on my distant to-do list to have a go at. And I know wood is not a very promising material for making machinery, but I just saw it as an interesting challenge that I'd like to have a go at sometime.
The best thing I can suggest to look at if you want to look at a wooden clock and how to possibly make one is the British Horological Institute at Upton, just outside Southwell in Nottinghamshire, do have a wooden clock that was somebody's window display. I mean, this thing's the size of a Welsh dresser. It's huge. But if you're interested, it's up there. It's up at the end of the red corridor, unless they've moved it. So yeah, that's the only wooden clock I can think of, and the only thing I've had to do with that is to literally pick it up and move it. And the thing weighs a proverbial ton.
Okay. Now this one that I've got the plans for is moderate in size.
I know the one you mean. I've seen the plans.
Yeah.
At some point.
Yeah. So I doubt if it'll make a very accurate timepiece, but it's just an interesting challenge, and
you'd be surprised.
Yeah. Yeah. Okay. Thanks very much.
No problem at all.
We will now move over to Eric. Chester, I'll come back to you at the end. Eric, there we go.
Okay, thanks. Hi, Ross. That fascinating talk. I think it's an endless topic, looking at the clocks and watches and how they work. On the one hand, it's fairly simple. On the other hand, it's almost magical. Yes, I'd loved hearing about that. I've always quite fancied making a clock, but not making the mechanism, making the case. And I was wondering if you had any sources for sort of reasonably priced clock mechanisms for just a wind-up traditional clock?
Yes, I do.
Cool.
Depends what you call reasonable. But Cousins Material House, based in Romford, do mechanical clock movements complete to order.
All right, right.
Well, I say complete. You buy the movement, and you can choose the movement. Okay, I'll just open it up at one page, but there's 4 or 5 pages of movements: striking, chiming, weight-driven, spring-driven. Then you'd have to buy the. They'd also sell the gongs, the pendulum bobs, all to match.
All right. Okay, that sounds exactly like the sort of thing I'm looking for. When they say made to order, that does sound what might be at the top of my price range, but we'll see. I suppose that was reflected in what I did with it.
I ordered a chiming one last week. It was 220 quid plus VAT plus shipping.
That's doable. It's not too bad.
The shipping was about 10 quid.
Right. Excellent. Okay. I'll maybe try that. Add that to my list of projects and things to make.
The other one that I can suggest is Frank at Oakside Clocks. Now, Frank, you get a bloke and you can ring him up and go, I want this clock movement. What do I need to go with it? Whereas at Cousins, you've got to work it out yourself.
Oh. All right. Okay. No, that sounds helpful as well. Oh, and thanks, Matthias, as well. We got helpful advice in the comments there. No, I just like the things moving. I've always had a sort of ticking clock, a pendulum clock in my bedroom, and I find it very restful. Other folk in my bedroom don't, so it's now been put elsewhere. I've been married for 30 years, so I haven't had it in the bedroom for a while. It's behind me now as I'm sitting, but I love the idea of ticking and movement, and I'd often thought about trying to do a wooden sort of kinetic sculpture, but based on clockwork. So that might be, that's a lot easier than trying to make an actual clock.
There is someone, I can't remember who it is on the internet, that does do kinetic wooden sculptures based on clockwork.
Yeah, I've seen a few. So some of them are really, really beautiful. But right, okay, I think I've probably hogged you long enough, Ross. So thanks very much. Fascinating. And really, I've got my list of books to try and get hold of as well now. Probably much more than I need, too technical, but we'll see.
They're not bad, those books.
Okay, I'll take you at your word.
You might have to read stuff 2 or 3 times to actually get it to make sense.
Right.
But they are written for people entering the trade.
Right. Oh well, that's good. I'm certainly novice. Right. Thanks very much indeed.
No problem at all.
Right, we're over to Ireland with Richard Murray. Here we go. Richard, yep. You're muted.
Am I unmuted yet?
That's better. Can it? No, now you've done it again.
You muted yourself again, Richard.
Mute. Okay, is that better?
That's better.
Okay. Unfortunately, I was called away for about 10 minutes while you were talking. So I don't know if I missed you talking about chimes, but I was just wondering, do chimes exponentially add to the complexity of clocks, or are chimes quite a simple mechanism as well?
Depends what you mean by chime, because they mean something very specific to a clockmaker. So a clock that strikes the hour has only got striking. Chiming would play Westminster, St Michael's, Whittington every quarter.
Got you.
So they make a clock look very, very complicated. But once you understand the principles, they're actually really simple. And if you break it down and think of it like a computer, a chiming clock would have 3 programs. The program that drives the hands, that trips off the program that chimes the quarters, which then trips off the program that strikes the hours. And you think that they are 3 individual bits, and then all the levers on the front that look really complicated, just connect them all together. So yes, they look daunting when you're not used to them. Yes, they are complicated, but I take one apart and throw it all in one tray and then sit there and sort it out.
Okay.
They get more complicated and more difficult when you get different let-off methods. So the standard one is you get it runs up to the hour, you hear it go click, whir, stop. And that's the clock running to warn and getting ready to strike. And what it's done is lift all the levers, dropped everything it needs to drop in plenty of time, and then it sets off on the hour. If clocks have got pull repeats, because obviously they were made when there was no electric light, you get something called a flirt set off, where instead of lifting the levers, it pulls a piece down on a spring and then it fires it up to set everything off. And they do get complicated because if the spring's not strong enough, it doesn't lift all the levers, so the clock doesn't chime. And if it's too strong, it can go up and come down so fast that you get the wrong numbers because it's not giving them enough time to fall under gravity or under their own spring tension. And they can be quite difficult and complicated to set up, especially if they're striking chiming grand sonnery. So you get the quarter and the hour every quarter. They can get quite difficult to set up. But no, it's just 3 computer programs. They just happen to be mechanical.
Okay.
It's the best way I can think of explaining it. I haven't got one up here to show you, but they're not. There's more to go wrong. I'll give it that much. And it tends to be the strike and the chime that upset a clock rather than the time side. Does that answer the question?
It does, yes. It's just that I grew up in a home that had a clock that struck on the quarter of an hour, and I just took it for granted then. But thinking back, I wish I had opened up the back and had a look at it as a teenager, but I never did.
A lot of it is actually hidden on the front plate. Even if you open the back, you wouldn't see it. A lot of the mechanism is actually hidden on the front plate with all the levers, because that's where everything comes out of the movement. If you ever find one, take it out of the case and have a look. Just if you're taking it out of the case, if you're ever taking a clock out of the case that's got springs in, be very wary of the springs because they are lethal. I've known customers who've had broken fingers and broken wrists because springs have gone bang. And that's with the clock. And that's with the clock in the case. So always make sure the spring is right off before you do anything.
Thank you.
No problem.
Hi, cheers, Richard. I am going to squeeze in a question myself before we move on to Chester as the last question for tonight, his second question for tonight. My question is, well, I grew up always wanting to build a cuckoo clock.
Right.
At some point. How complex would that be?
Which bit do you want to build?
The whole thing. Including the woodworking thing, the woodworking side, I'm sure I could do. But the mechanism itself.
The mechanisms aren't complicated, but I'd buy one. It's cheaper, it's easier. You've then still got to fit it into the case. That hook and spike clock that I showed you in Fusion is designed to be built one-to-one with me in a week. And that's a full 40-hour, 45-hour week. Your problem with a cuckoo clock is A, there's more to do. B, most of it's bent bits of wire to make everything work because you've got the bellows and the cuckoo to do. You'd need my next door neighbours to do the cuckoo work because they're organ builders. It's a lot of work. It's a challenge. I wouldn't say it's not doable because everything's doable if you're prepared to throw enough time at it.
And the second you wanted to ask me was you mentioned lignum vitae earlier. You reckon that you could actually approach it just like metal and make an identical clock mechanism to the type that you make now, and use a timber which is, you know, similar in hardness to lignum or lignum itself?
Sorry, I missed the first part of the question.
So could you make a clock mechanism using lignum, but approaching it the same way that you do with metal?
Don't see why not. It's only another material. I've turned oak on the lathe. I've turned beech. I'd have to experiment. I have to find some lignum for a start, but I don't see why we couldn't.
Okay. Interesting. Well, thank you very much. We'll move over to Chester. Last question for tonight. Here we go, Chester.
Thank you. It just occurred to me after we talked that one of the things that I've been concerned with a lot of my clocks is the level or plumbness of them. Can you talk a little bit about the effect of a clock being out of plumb? Because cuckoo clocks or wall hung clocks generally, if the wall is out of plumb forward and back, it could affect it, or side to side. And all of the clocks I have that are mantle clocks have adjusters on the bottom to level.
Right. Out of plumb front to back isn't a problem, providing the pendulum doesn't scrape the wall or the case or the weights, whichever one it's going to hit first. Left to right, I'm not worried, as a clockmaker, I'm not worried about it being plumb, because I can set the clock up to make the what we call the beat even, which is what the adjusters are for on your mantle clocks. The other one you see is people have 2p pieces or old pennies shoved under one side to tip it up slightly. And what you're doing there, if you listen to a clock and don't go tick-tock in your mind, go left-right, it wants to sound like a military marching band. Dead even, marching through time. If it's out of beat, you get tick, tock, tick, tock, tick, or a military band with a very severe limp. And what you do by twisting the case up and down, the pendulum is effectively a plumb bob. At rest, it will always hang vertically. And you've got the pendulum. Let me hang on a second. Share screen. That one. It's all right. It's easier to show you with this. That one. Turn off that. Turn off that. Let me find what I'm looking for. Skate wheel. Collet, pallets. Crutch collet. Crutch fork. Right. So pallets, skate wheel, pendulum. The pendulum will always hang as a plumb rod. As a plumb bob. But the pendulum and the crutch aren't actually connected. It's just a slot that the pendulum goes through. So if you bend that crutch slightly, if you bend it to the left, you'll actually make the entrance pallet go deeper when it's at rest. So it takes longer to pull out, which is why you get that long gap between the tick, and then it jump forward and catch, and then it's gone again. Yeah.
Yeah.
So what you're doing by hanging it on the wall at an angle or jacking one side up is effectively setting the beat of the clock so that the entrance pallet and the exit pallet go into the escape wheel the same amount every time on both sides, rather than one side being much deeper than the other. Do you see that?
Yeah, and it makes me think that it's very difficult in casework. If you put a level or a plumb on the side of the case, that doesn't mean that the mechanism inside is going to be actually true to the case. So you have to listen to it, like you say.
You have to listen to it. And if you stand and look at the front of the clock and listen to it and watch it and work out which way the long tick is, so if it's from left to right, you then need to bend the bottom of the crutch towards the right slightly, which then, when it comes back to rest, pull the entrance pallet out a little bit. Does that make sense?
Yes, absolutely.
And it's a subtle bend. If you feel it bend, you've probably gone too far. And I tend to do it. I will reach around the back of the clock and put my thumbs in, and just one thumb in the middle of the crutch and one thumb at the bottom, and just press it against the thumb just until we get to that plastic limit of the metal, and you can do it both ways. And sometimes you end up hunting, but yeah, you have to sit back and listen to it. But I wouldn't worry about a plumb case. I'd make it look upright and then set the clock up to the case.
Gotcha. The old craft style one that I have, the mission style, I've got little pieces of wood, thin pieces that I keep rearranging on the 4 feet, but I never seem to really get it actually plumb because the case in the top of it is not necessarily square, being 100 years old.
Yeah, I generally work on, particularly for a wall clock, if you stand the other side of the room and look at it, if it looks upright, it's near enough to fit the clock into.
Very good.
So I don't actually have the spirit level in my toolbox. I just walk down the room and go, yeah, that looks about upright. That's near enough. I can make the clock work. Whereas if you get them up level.
And forward and back is not an issue, as long as it's not severe.
Yeah, I mean, some particularly long case clocks, you find the pendulums get very close to the backboard. So any lean backwards and they rub. And that'll stop the clock. So in that instance, you actually want them to lean forward just a fraction to give you a bit of clearance. But I'm talking 1/10 of a degree.
Right.
Because you're working over sort of, nearly 3 feet on a case clock.
Right. That's great. Great lessons.
No problem.
Thank you, Russ.
Has everybody frozen now?
Thank you, Shrenik.
Well, I'm just going to remove the spotlights and bring this to a close. Well, so thank you very much, Ross, for an incredible evening, incredible talk. And I hope this helps to keep horology, the trade of horology, alive a little bit longer, and so people can learn about it too. And I hope it's inspired some people to actually go on and maybe make a clock. So as our usual way to say cheers is to say cheers to Ross and glasses or bench beverages and say cheers to the bench. Cheers.
Cheers to the bench.
Cheers to the bench. Thank you, Ross.